Let's see what's going on here. We've got a medical researcher who believes that the human immune system produces antibodies to a particular vaccine at a rate of, given by this function here. All right, so it's a rate because it's a derivative, thousands per day. All right, produces antibodies at this rate, thousands per day. Assuming that when no vaccine is administered, the immune system produces no antibodies. All right, that is our initial conditions. When no vaccine is administered, no antibodies. That is, assume that when t equals 0, right, t equals 0, that's the time after the vaccine was given, the number of antibodies is 0. Okay, so the first step, specify the function that describes the antibody production. Okay, this function here describes the rate of change of antibody production. We want the function itself. So we have to find n of t. So let's integrate here. We know that n of t is going to be the integral of n prime of t dt. All right, so that is going to give us, all right, we're going to integrate, what have we got here? This quotient, 2,000 over 20t plus 15 dt. Now, this is a quotient, and we know we're going to make a u substitution by letting u equal the denominator. So let u equal 20t plus 15. Okay, and now we know we're going to need the derivative, so let's just go ahead and get this. What is du, not dx this time, but du dt? That turns out to be 20. And then I'll multiply by dt, so I'll get du is equal to 20 dt. Now, here's where we are so far. I've got that 2,000. I'm going to write this over u, and then I still have the dt, right? If I just substitute, I've got the 2,000 dt, and then I let that be u. That takes us down here. So this is what I want, right? I need to get everything in terms of u. Well, I've got the denominator here in u, but I need to get this. That's what I want. What have I got? When I take the derivative over here, I get 20 dt. That's what I have. What I want is 2,000 dt. Well, we're almost there. Why don't we just do this? Why don't we multiply by 100? So I'll get 100 du is equal to, right, 100 times 20 dt. That gives us 2,000 dt. So here's what I want. Here's what I have. So the 2,000 dt turns out to be 100 du. All right, so here's where we are now. We are at, I've got 1 over u times, and then what was this? What was the 2,000 dt? 2,000 dt was 100 du. So that's 100 du. So I'm going to write this as 100 times the integral of 1 over u du. Now this will give us 100 times the natural log of the absolute value of u plus c. But let's resubstitute. So 100 times the natural log of the absolute value of, let's go back and get our u. What was u? Back over here, 20t plus 15. 20t plus 15, all right, plus c. And this is our n of t. Okay, so we got the family, but what we need to do is we need to get this. We need to get c. We can get that from our initial conditions, and we're given that when t equals 0, n is equal to 0. So let's substitute. We'll put, made a mess. We'll put that 0 in here and 0 in here. So this is going to give us 0 is equal to 100 natural log of the absolute value of 20 times 0 plus 15 plus c. So this will give us 0 equals 100 times the natural log of 20 times 0 is 0. We'll get the natural log of 15 plus c. So c will be negative 100 natural log of 15, right? I can take those absolute values off because 15 is positive. So now here is our function. N of t is going to be 100 times the natural log of what do we get here now? Everything's positive, so I can write absolute values, but I don't need to because everything's positive. So I'll get 20t plus 15, and then c, which is negative 100 times the natural log of 15. There's our n. Then, that's part A. And in part B, I'll do that way up here at the top. What I want to do here is find the number of antibodies produced 5 days after vaccination. So we want n of 5. So what we're going to do is we're going to put that 5 right in here and compute. It's going to look like this. It's going to be 100 times the natural log of 20 times 5 plus 15 minus 100 times the natural log of 15. And when I computed that, I got about 203.688, but we're going to round, so 203.69.